Hello students, this is going to be a little discussion of how to use StatCrunch. So StatCrunch was developed somewhere else, and it was bought by Pearson, and they're using it now to support their statistics classes, and they still support StatCrunch. I've already made a request to them to make a couple of changes some things that I found, but really for the most part it's a very good package. I think we'll find it fairly easy to use, and it's great the way that it's tied into the Pearson homework problems and so on. So I'm going to show you a little bit about how to use it. So the general way of accessing it is through the Vital Book Source link right here. So when I click on that, something should happen. And it will come right here, and it will say this, and this is how you get into Pearson. You say launch courseware. We're not at StatCrunch yet, but when I get to my Pearson account, you see that I have some instructor tools here. I'm going to open My Lab and Mastering. There's a good chance you'll already be in here, and you see on the side here that there is StatCrunch. So if you click on that, we're getting closer. And here's a couple of things to know. First of all, right here you can access the data text sets from your textbook through this link right here. Alright, so that's one way to get in there, is to, if you want to open a data set from your textbook. It'll show all the data sets from all of the homework problems, including some that aren't assigned to you. But we're going to click here on Visit the StatCrunch website. So this will work through a website. We're almost there, and then I click on Open StatCrunch, and it opens. So there, we're finally there. This thing looks like a spreadsheet. If you've been in Excel, it looks like that. The difference is that each column, you can't just randomly put things in here. Each column is designated as a variable. You see by generically they're listed as variable 1 through variable however many, and then each row, starting with row 1, is an observation. So that's the typical way we've talked about data is organized for a statistical analysis. Now for our analysis here, for our benefit, I actually put this data set out so that everyone could access it. So another way to get in is to have a data set link that we have. So I took this data set that we're going to use, and I put it out on, and so this is a long-winded link here. And if you double click on this thing, let's see, well, the best site is to highlight this and say go to, and there we go. So it's going to go to that and open it up, and any of you can do this if you want to either practice what we're doing here, or you want to try it later. I mean, you can follow along right now, or you can try it later, but let's do some graphs on this data. So what this data is this is going back to almost the last century, to about 1920. I think the earliest one here on here is Melvin Ballard in 1919, and all the apostles who were called and the age at which they were called. Now Thomas S. Monson was called at age 36. That's the youngest on here, and so one of the questions is that an outlier? And certainly he's the youngest, but is it that unusual compared to the ages of other apostles? So we're going to look at this data graphically, and we'll look at the three numerical graphs that we studied in chapter 2. Let's start with the dot plot. So I'm going to say graph dot plot. I'm going to select the column called age when called, and really for the dot plot there's not a lot to put on there. You can put the mean and median on there should you choose to, but let's just do it without that. And there we have our dot plot. One of the things about the dot plot, again, is you wouldn't expect a lot of numbers at the same age, but there are 4 here at age at this age. This is 54, and there were 4 that were called at 29. 3 here at, so you can see the different values here. Here is Thomas Monson down here. It definitely looks like a little pretty unusual on the low side. And there also happens to be a high one. By the way, you can see if you put the cursor over it, it says that's row 31. this one is row 27. So I can go over and look at that and say, oh, 27 is Thomas Monson. We knew that. Row 31, there was an apostle called by the name of George Morris in 1954 who was 80 years old. And so that's pretty unusual on the high side. So those both might be considered to be unusual. And there's also one other high one here, which was 75. That's row 30. Hugh B. Brown was called in 1958 as an apostle. I believe he had already served in the first presidency by that point, but may not have been called an apostle before that. I'd have to go back and check my history to be sure on that. But you see the data. Let's get with something that will compile it a little bit more, and let's do the stem and leaf diagram. So the stem and leaf plot is shown right here. Age when called. Again, I don't have to, I'm going to go with the defaults here. And this is nice because it gives us some shape here. You see the shape, and you see that it's a fairly symmetric distribution, although there's quite a few here in the 60 to 65 age group. That's your mode, is the range from 60 to 65. And but then it goes down, and the number that we're called older and smaller ages goes down in both directions, kind of a symmetric distribution. It's just slightly skewed, but not a real long tail, and so on. So that stem and leaf diagram is really nice because it preserves all of the data. And finally, we'll do a histogram on this data, which is really good for telling us the shape. So I go back over here and say, give me a histogram. We'll do a little bit more with this one. Age when called. Now, there's a number of things that you can put on this histogram as well. But let's just start by saying what it gives us as a default. And there's our histogram. This is very nice in the sense that it groups the data very nicely. It really looks exactly like the stem and leaf because these are the same categories the stem and leaf use. So this is everyone from 35 to 40. You notice when you put your cursor over that, it says 35 to 40. It's got a bracket on the left side and a parenthesis on the right. What that means is that 35 is included on the left, but 40 is not included on the right. So 40 would be included in this group, and that's what the bracket means versus the parentheses. So where the data comes in is integer values. You see here what it is doing is it's using the borders, and so it's included on the left but not included on the right when you do this. So this looks exactly like the stem and leaf did. That shows you I think in some ways the validity of the stem and leaf. Now, you're going to have some homework problems where it asks you to change some things on this graph. And if you've already produced a graph, you can click on Options and click under Edit and make some changes. So in this particular case, let me just go back for a second. Say, what if I wanted, instead of 40 being the edge of the group, what if I like the groups, but I'd like the 40 to be in the middle of a group. So in other words, I'll go 32.5 to 37.5, 37.5 to 40. How would I make that happen? Well, I'm going to go back to the Edit module. I'm going to say, I want to start the bins at 32.5. Remember, the lowest was Thomas Monson, and I can put that optional, but I'll make it for certain. I'll say make the width 5. So what it's going to do now is shift everything over by 2.5 units, so that let's do compute. Now you see that 40 is at the center of the group. So this says it includes everybody from 37.5 to 42.5. So the ambiguity is done because there is nobody at 37.5, right? The data was only collected to the nearest year. So the ambiguity is gone as to who's included where. And you might like this graph a little bit better. And now you see there are two groups that are tied here, 62.5 to 67.5, 67.5 to, excuse me, this is 57.5 to 62.5. There are 11 of those. And 62.5 to 67.5, there are also 11 of those. So that's where the peak is on the distribution. So this is a little bit of a left skewed distribution. We got a little bit longer tail on this side than we do on this side to relate it to what we discussed in Chapter 2. But these options are how you can change the characteristics, and you might need to do that in some of the homework problems to make your bar charts look more like the ones that Pearson is asking for. Now, there's also, I'm just going to show you that I can add the mean and the median to this. Now, we haven't talked much about mean and medians. The median is the middle value, and the mean is the average. Middle value. So you see that they're very close to one another, and you can see here that the average is 57.4, and the median is 58. That's the middle value. So half of the apostles were called at age 58 and above, and the other half were called at age 58 and below. That's the break-even point. And so the fact that the mean and the median are about the same is one indication that this distribution is fairly symmetric. Again, the skew is only slight on this, and so on. So that's the fundamentals. You see that we link directly to this data set on Canvas. I put a link there so you could open it. I'll probably do that more times this semester as other data sets come up. In fact, I know I'm going to create a data set on our introductory quiz with all of your information so that we can do some work on that once I get it all compiled and you all fill out your questionnaires. I know some of you haven't done that yet, but in any event, we will have other data sets in there in that StatCrunch part of our Canvas. So let me stop right there, and if you have any questions that come up on StatCrunch, don't hesitate to let me know or to talk to our tutors in the math lab.